Hello everyone. In this video I want to show you three options for plotting an animation that are new, and I have not discussed them in my previous videos. One of them is this new graphic or animation command they have added called animatedline. So this is for animation. If you want to create a plot of a function or any graph, and you want to gradually add the data to it and complete it, okay? So this is different from my previous animations where like I had a graph and then I had like a particle moving on it or something, right? Or some parameter of the graph was changing, showing some animation. So this is gradually completing the graph by adding points to it. So here, you see I create, using this command animatedline, I create a handle, and then I want to plot my sine function between the range 0 to 6 pi. And so I have all the labels and everything and limit the axis, and I want 100 points to be added to the plot. So here I define my x and y, and then using a for loop, I keep adding these points to the animated line. So what should I say? I say for k equal 1 to the number of points, add points. This is another built-in function. Add points to the h, which point? X, k, and y, k. So when k is 1, I add the first point, then I add the second point, third point, and then to update the graph, I have to use, like previous animation videos, I have to use the command draw now. And here I use a pause to slow it down, okay? So let's go ahead and run this together, see what you get. So here, click here, and then run section. And this is the graph, you can see. See, those points are added one by one, and this one is created gradually, right? If you want to slow it further down, you can go up on this pause, and you should be able to slow it further down. You see, so it's like gradually drawing the sine function for you. And so this is a new kind of animation that MATLAB has added. Just wanted to show you that. And one other thing is, can you change the line parameters on it? Yes. So when you say animated line, you can pass some inputs to it. For example, you can add a marker to it, you can change the color of it, you can change the line width, and so on. So here, if instead of that line, I use this one, I should get a little bit different plot, right? So here, let's take a look. You see? So now I have red circle markers and line width 2. Okay, so you can pass inputs to the command animated line. Okay, so this is for animated line. Now let's talk about the next thing, which is double y-axis. Sometimes you have seen probably plots on the internet where you have the x-axis, and then on the left side of the x-axis you have y-axis, and then on the right side of the x-axis you have another y-axis. So basically you're plotting two different basically dependent variable versus one single independent variable. And each one of those axes, they have their own scales, so they are not the same scale. And you can do that using this command called yyaxis. So let's say here my first function is sine function, which is only between -1 to 1. The other one is x cosine of x, which between 0 to 2 pi, it changes, right? So it goes from basically at 0 it's 0, but at 2 pi it's 2 pi, right? And this one changes, and at pi it's like -pi. So the scale of these two are not the same. And I want to show both of them next to each other in the same plot, but each one on a separate y-axis. So I define them first and create a figure, then say y-axis left. So first I look at the left side and say, on that one, plot for me x versus y1. You can add your x and y label. Now each one of them has a separate y label. In this case, your x label is the same for both of them. So you just need to do it one time. But you see, I do a Y label for the left axis, then I go say y axis right. For this one, plot y2. For this one, I have a separate Y label. Then for the whole figure, I have the same what? Title. So if I run this section now, look. Here. You see, it shows the two graphs. And you see that the scaling is different. This guy, the blue, goes only -1 to 1, while the, you might call it orange or brown, it goes from like -4 to 8 or something, right? Or here from, as I said, -pi to +2 pi. Okay, so clearly I can do this double y-axis graph if you want. This is another advanced option I wanted to tell you. And finally, when you create a plot, there are two tools that I have not talked about them so far. One of them is the brush tool and the other one is link. What are these? What do they do? Let me show you. So here, let's create X and Y like this. Okay, and then do a scatter plot of what? X and Y like that. So this is the scatter plot of X and Y, and let's also add these labels as well, so it's more informative. So now, let's say these are some data I have, and for example, this data here is an outlier. So I want to get rid of that outlier. Well, what should I do? Well, if I know where that data is, right, I say, for example, get rid of X number 3 and get rid of Y number 3. I can set them equal to an empty bracket. But if the data has lots and lots of data points, right, and it's very busy, can I do that from the graph? Can I just click on the data in the graph and get rid of it? You might say yes, you can. And the way to do it is click on this brush data, and then highlight this data point. You see it's gone red. Now you can right click on this and you can replace it with a constant or NaN. You can color it, you can remove it, you can export it, you can copy it to a clipboard, you can post it to the command line, or you can do all sorts of things to it. But look, my goal here is to get rid of it. So I say remove brushed, right? Say remove brushed. And look, it got rid of that data, right? You have now only 7 data points instead of 8. But if I look at my original data that I defined in the function, if you look at them, the data point that was 12, it's still there, right? So if I look at my Y data and X data, they still have that outlier. So removing it from the graph does not mean you removed it from the original data, okay? So if you want to get rid of it here in the plot and directly get rid of it in the original data, the brush is not enough. So what should I do? Let me show you. So if you want to do that, then let's do it again. What you need to do is, first you want to link your graph data to your data in the workspace. Right now they are not linked. The plot is generated, but now they are not linked together. So you go to Tools, and here you see there is this tool called Link. So you click on the link, a symbol appears here, which is for the link. And that allows you, look here, that guy. Now your data is linked to the workspace. Now, if I go and grab my brush, you see here, by the way, before you can do that, it asks you, hey, what do you want the X and Y of this plot to be linked to in the workspace? And you say, well, the X of it, the horizontal axis, should be the X on the workspace, and Y of it should be Y. Okay, this is good. So you okay that. Now the link is there. Now you click on the brush, you mark this data, right? Now if I right click here and remove the brush, look what happens. So here you get this one. It says at least one graphic object must be brushed, and we did. We okayed that, and we removed it, right? There we go. So now we have 7 data points, but now if I go back and look at my X or Y, or we can look at them here, look, you see that 12 is gone. That 12 that we had is now not in the Y, and the corresponding X for it, which was 3, right? You see that's also gone. We jump from 2 to 4. So by linking and brushing and removing, you can, let's say, get rid of an outlier data directly in the graph and also in the workspace. So this was another advanced option in the plots that I wanted to share with you. Hopefully it was useful to you, and I will see you in my next video. Thank you.